Hey, this is Mr. Drogemeyer. Thanks for joining me for our Algebra 1 lesson videos. Today we're looking at Unit 5, Lessons 16 and 17, Applying Linear Functions. So this whole unit we've been looking at different aspects of linear functions. Now we want to look at how we can apply them to help us solve real-world situations, figure things out. So let's go ahead and jump in. Our first one here says a factory has an order to produce 22,250 units of one of its products. The factory has 1,875 units already produced and can produce an additional 150 units each hour. We want to write a function that models the number of units left to build as a function of the number of hours of production. All right, so let's think about, first of all, let's define a variable. So we want to figure out the number of units based off of the number of hours. So let's have h is going to represent our number of hours, and we'll have our function f of h that's going to tell us our units. All right, and so if we look at what we're trying to produce, we're trying to get to 22,250 units. We already have that 1875, and we can produce 150 units each hour. So we want to write that function. So our f of h is the 22,250. And to get there, we're going to start with our rate of change, 150 units each hour. We're going to take that times the number of hours, and what we produce there is going to be added to the 1875 that we already have. And so this would be our function that we could use to figure out how many hours it would take us to build the remaining units that we need for our order. All right, and it doesn't ask us to actually solve this. We would go ahead and solve it for h by subtracting the 1875 from each side and then dividing each side by 150 to find the number of hours. All right, in the second one, it says that a company can make one of two products using the same resources. It can make X of product A and Y of product B. The amount it can make of either or both follows the equation 32x plus 24y equals 704. All right, so if we look at this equation they gave us, so this is telling us that this is product A, this is product B. We want to know what is the most that it can make of product A. Well, if we're just making product A, that's how we would make the most of it. That means that we're making none of product B. And so really what we're finding here is an intercept. We're going to plug in 0 for y. So 24 times y is 0. That just zeroes out, and we're left with 32x equals 704. And now if we divide each side by 32, so 704 divided by 32 is 22. So the most that we can make of that product is 22. So 22 of product A. And that really is telling us what our x-intercept is if we were looking at this on a graph. So that's a great way that we can use that linear function as a comparison there. All right, and then our last one here tells us that the point slope of an unknown line, point slope form of an unknown line is y plus 5 equals mx plus 3. So I'm going to write that equation. Y plus 5 equals m times x plus 3. We want to know what's the value of m if the sample point that they used was -4, -9. Well, what we can do is we can plug in that -4 and -9 into our equation for y and for x so that we can figure out what m would be. So we're going to plug in -9 for y, that's our y value. And then we're going to plug in -4 for x. And now we're going to go ahead and do our calculations here. -5 plus 4 is -4. We still have m here. -4 plus 3 is -1. So this is -1m equals -4. I would divide each side by -1 to get m by itself. -4 divided by -1 tells me I have a positive 4 slope. And so the value of m in our equation would be 4. So if we were going to plug it back into our original equation, the equation of that line would look like this. All right, that's all I got for you on this one. Appreciate you taking the time to watch. Thanks. Have a great day.